Hello guys, welcome to Past Paper Question Series Episode 1. In this series, we are going to start with a question which is of great intrigue to us, and I hope you will enjoy this question. This question belongs to AP Chemistry Past Paper 2024, and the question states that there is a student. Now, there's one more thing before I begin, that this question is actually a part of a huge question. We might discuss the huge question as well, but this part is of most intrigue and perhaps most difficult for most of the students. So we are going to discuss this part in detail. The question says that there is a student who pours sodium hydroxide solution into a burette and fills it up to the mark of 100 ml. Then he takes some amount of lactic acid, actually not some amount, but 25 ml of lactic acid in an earthenware flask. And then he starts titrating this lactic acid against sodium hydroxide solution. While he was titrating, he plotted a graph between the volume of sodium hydroxide in ml on x-axis and the pH, which is changing, of course, continuously throughout this experiment on the y-axis. The examiner says that we have to tell that what is the pKa value of lactic acid. So, before going forward and getting confused with this graph, you have to identify that what kind of titration is this. So, here there is a strong base, which is sodium hydroxide, and there is a weak acid, which is lactic acid. Hence, this titration is between a weak acid and a strong base. Now, always remember that when you are given the titration between a weak acid and a strong base, the pKa value is equal to the midpoint of the equivalence point and the initial point of the titration. Now, what does this mean? To understand this, look at the graph. The initial point of the experiment is when there was no NaOH poured into the earthenware flask, which is of course at 0 ml, while the equivalence point is at 16 ml. As you might know, that equivalence point is the point where there is a sudden change in pH, which is quite visible by the graph. There's one more thing. Before we move onwards, you can see that there are three parts to this titration curve. The first one is this, the second one is this one, which is the equivalence point, and the third is this one. Before the equivalence point, the solution is majorly acidic, while after the equivalence point, the solution is mainly basic. So, coming back to the main point, the pKa will be calculated by looking at the midpoint of the equivalence point and the initial point. And as you can see that the equivalence point approaches at when 16 ml of sodium hydroxide has been used, while the initial point is when 0 ml of sodium hydroxide was used, or simply no sodium hydroxide was used. So, the midpoint is 8 ml. When 8 ml of sodium hydroxide was used, and the pH at that point will be equal to the pKa. Now that is very intriguing. When you look at the graph, then look, the pH at 8 ml of sodium hydroxide usage is 3.8. Hence, our answer is 3.8. Now, there's a tip that you must always remember. Remember that the pKa will be equal to the midpoint of the equivalence point and the initial point only and only when you are studying a titration between a weak acid and a strong base, such as the one in this case, or between a weak acid or a weak base. In other kind of titration, you cannot go with this assumption. And in order to further elaborate this mathematically, use the Hazel-Bath equation. And if you comment me, then I can explain this more in a much more mathematical manner up ahead. So for now, follow our videos, follow our account, save our reels, comment us so that we could make more interesting content, and save and share our profile. Thank you.